We at the Sharjah Research and Technology Park focus on four main objectives. The first objective is to develop an innovation ecosystem, not only based on the infrastructure of building and the street, but also the mindset of people. We also aim at developing next generation scientists, entrepreneurs, and leaders. Our third objective is to focus on catalyzing knowledge economy, investing in technology and science and entrepreneurs so that we can have an impact and create enterprises that support the economy of the country and Sharjah and make it more competitive. Our fourth objective is really to invest in the future. We identify companies, we vet them, invest in these companies, and we scale them up. We at the Sharjah Research and Technology Park focus on six main subjects. The first one is water technology, the second one, production design and architecture, the third one is mobility logistics and smart city, the fourth one is healthcare and digitization, and fifth one is renewable energy, and last but not least, environmental technology and circular economy. These are the six areas we focus on. We believe our colleges, our private sector have a competitive edge to grow and develop. We believe in entrepreneurs. We work with government, private sector, academia, and then for-profit organization to develop our ecosystem of innovation. We have launched research activities with universities, and we're trying to commercialize this research. We also engage with government and implementing best practices when it comes to artificial intelligence, blockchain. We launch sandbox with ministries, and we work with businesses as well in developing and professionalizing technologies that will make them more sustained and more competitive going forward. We pride ourselves to be able to attract some of the leading technologies into our park, whether we're talking about 3D construction, additive manufacturing, agriculture technologies, photovoltaic R&D center, transport and mobility technologies, or mixed realities. We pride ourselves to be part of a 47,000 students ecosystem at 22 universities and education institutions and more than 2,000 PhD holders, all in the same place within the vicinity of the technology park. The Sharjah Research and Technology Park managed to attract global players, regional players, and local players. We pride ourselves to work with international companies like TE, like Intel, and Nokia, for example. We work with GE on additive manufacturing. We work with Intel on solutions related to applications and reskilling, and we work with Nokia, for example, on IoT labs and other things. We also have regional companies leading in additive manufacturing like Anessa. We have also mobile fueling companies like Carrefour, and also we have companies in health like Nefta. We also have local startups that are thriving and really defining the way forward. At SRTIP, we believe to have a global vision and regional vision. We believe in partnerships. That's why we work with countries, academic institutions, science institutions, and with UN-led organizations as well. We developed the Sharjah Research and Technology Park based on best practices, and we managed to benchmark Sharjah against 9 other cities around the world, from Boston to Marseille to Shenzhen to Bangalore to Hyderabad to Philadelphia. We looked at 6 main innovation criteria, like market investment, interfair activity, merger R&D, human skills, infrastructure, and we looked at these things and we benchmarked with other nations around us to see where Sharjah is vis-a-vis this nation and learn from these activities as we go on. Here are some examples of the bright technologies that we are developing here in Sharjah. We in Sharjah are developing next generation technology that will be promoted in this region and will become an integral part of the mobility solution in the Middle East. We also pride ourselves on significant investment and technology development in hydroponics and aquaponics and agriculture technology. We believe that the Middle East food security insists that we develop these type of technologies, and we work hand in hand with the private sector and with academia to develop these technologies here. We also develop a photovoltaic R&D center. Our aim is to promote renewable diversity and bring new source of sustainable diversity to the energy mix of the country. In the park, we pride ourselves to launch Energy Innovation Hub, a regional platform to engage and attract innovations into this region and link them to the industry of energy within the region. We also pride ourselves at the Sharjah Research and Technology Park, host one of the largest maker space in the UAE, the Sharjah Open Innovation Lab. This lab dedicated to entrepreneurs, to faculty, to companies to come and co-create and co-innovate the future of technology at the park. We develop and promote this soil lab by engaging with different players, whether you are an investor or a company or academia. They all come and co-create and create businesses and enterprise out of this lab, which features cutting-edge technologies in textile technologies, electronics, metal, 3D technologies, and others. For SRTIP, collaboration with academia is an integral part of our work. We work with universities in the UAE and around the world. For example, the American University of Sharjah is one of our key partners, and we work with them on four main areas. One around IP and commercialization, entrepreneurship and development of science, employment and internship, and also lab exchange. We believe to have innovation, we have to develop human capital and develop a strong link to academia and academic institutions. I would like to share with you some other examples of the innovation we have here. We've managed at SRPRT in collaboration with academia and industry to create a regional lab for construction of 3D materials. So we have rented many houses using 3D technologies. Another example of what we do is we develop IP, intellectual property, and commercialization of the IP, and the topic, for example, is conducted concrete. Another example of R&D is we have developed an exoskeleton technology that can apply for healthcare sector and also apply for industry within construction as well. And we do this in collaboration with academia and in collaboration with the private sector as well. The Sharjah Research and Technology Park also thrives on developing an ecosystem. I have spoken about the Middle East Energy Innovation Hub. This is a platform to develop new innovation within the energy sector. To be able to conduct our work at SRPRT, we have developed a comprehensive ecosystem that includes events and teams like the Women in Technology, promoting circular economy, and launching various accelerators. Our flagship accelerator is the Sharjah Advanced Industry Accelerator. We pride ourselves to be a home for the Middle East, North Africa, and Innovation Technology Pathway Summit. We want to position Sharjah as a platform for technology innovation and technology transfer in the whole Middle East. And we work with scientists, science institutions, academia, private sector to be able to do this. In addition to that, we run a series of events at the Sharjah Research and Technology Park. These comprise webinars, exhibitions, conferences that allow businesses and partners and tenants of SRPRT to engage and grow and develop their businesses and build up strong network with investors, businesses, academia, and government. We also launched the Sharjah Angel Investor to create funds and make funds available for startups to come and go out of Sharjah. We also host many delegations throughout the year at the Sharjah Research and Technology Park. We host a lot of webinars, and we aim to do more of these webinars to cement relationship with countries, with industries, and with different players. Sharjah Research and Technology Park also have fantastic facilities for exhibition. We host many exhibitions and conferences at the park, and we aim to continue doing that going forward. This is a summary of the Sharjah Research and Technology Park. I hope you enjoyed the presentation. We look forward to working with you, to partner with you, and grow with you. Thank you.
That was an introductory video to Sharjah Research and Innovation Park. Now we're going to give you guys an introduction to what our line of work is on, Sharjah Additive Manufacturing Hub. SAMHub. And I'll have my colleague Abdul Jalil introduce you guys to it.
So before I introduce you to the vision of the Sharjah Additive Manufacturing Hub, I'd like to tell you why it's so important at this time to have a hub of this kind. So this is really a pivotal time for the manufacturing industry. We're standing at an epicenter where our ideas, our designs, and our products can be represented in a digital space so easily. And then these representations can be converted increasingly fast into physical parts through the use of additive. So as the first truly digital production technology, additive has been reshaping industries and businesses, especially today. So as the Sharjah Additive Manufacturing Hub, we have the goal of bridging the private, governmental, and academic sectors together to share and transfer knowledge and expertise between them, with the aim of really boosting innovation in the region through additive. So the Sharjah Additive Manufacturing Hub really wants to be a center for excellence for all additive processes. And this means we want to be, providing trainings related to additive, kind of building a strong collaborative network where members from all these three different sectors can collaborate and exchange their expertise. So to do this, we follow the triple helix system. We work with our academic partners, especially since we're strategically, located in University City. We have knowledge partners who we support through their research projects, because research projects are essential to bringing innovations, new innovations into the additive market. We also work and value our government partners because really the government is the catalyst when it comes to bringing change, especially in technology. They're the ones who set the policies and the legislation and enable the technology to be applied. And last but not least, we work with private companies, manufacturers, innovation companies, because they're the ones who experience changes in their supply chain, and they are the ones who will be provided with a competitive edge at the end. As for the machinery that's available at the park, so we have some of the world's most advanced technology. I wouldn't just say in the region, but also globally. To begin with, we have the GE additive 3D printing machine. Now, this is the Concept Laser M1 cubing machine. It's capable of 3D printing using metal, especially for small to medium-sized parts. And the main advantage with this type of technology is that you're printing parts that are precise in their construction, and you're able to maintain a sort of consistency that you wouldn't find with other types of machines. In addition, we also have the M2 cubing machine. Now, these types of machines are also perfect for a variety of applications that require high accuracy, like aerospace and aeronautical or even automotive applications. Aside from the production, we also have machinery that is capable for post-processing products, such as the George Fisher Cut E600 machine. This EDM machine is used for post-processing and really removing supports once you build the product. And we also have a Epson Python furnace, which is used for heat treatment of the parts. These types of machines or heat treatment essentially are used to really change the physical properties of the parts, especially of their metals. And last but not least, we will shortly or very soon be integrating pursuing SLS machines so that we can start printing polymer products very soon, and we're excited to have this as part of our portfolio. And now the father will be continuing with why.
All right, guys, I'm Abdul Qadir, and I'm going to talk about why nowadays, and why we should move towards more of additive means of production than we do with traditional means. So during nowadays we live in Industry 4.0. Due to the advent of COVID-19, we've seen that anything can be locked down or taken away, and given many supply chain issues. Additive manufacturing has proven during this time, these tough and turbulent times, that this technology can be there for corporations and companies through their digitalization use, through its rapid prototyping, and its quick and easy means of production. So the use of this digital inventory can provide corporations an idea or a space to hold their drawings instead of having them manufactured or made in-house, which makes it easier and more available on demand. Now, UAE and additive. When you think of additive manufacturing countries that have pushed this technology further, one might think of the USA or China or Germany. But the UAE is placing its feet on the ground when it comes to this technology and has its own goals set by 2030 to become a key power figure in the additive manufacturing space. And through the UAE pushing these kinds of technologies here and embracing companies that do so, we can see substantial progression in this field in the coming years. And the advantages we have of additive, first of all, in brainstorming capabilities. It's much easier to be able to create something on software than it is to create it by your own hands. So any mistake, any error can easily be went back on, changed easily just by a few clicks or a few swipes. This gives us the idea to be able to create more unique images, more unique renders of parts, and to be able to think outside the box, as well as rapid prototyping. Any mistake that's done through traditional means of manufacturing and traditional means of production would be very difficult to fix later on, meaning you'd have to replace the entire part or change a few things here and there. But with additive manufacturing, it's easy. If you make a mistake in a final piece, you can just print it again and fix any issues through the software, as well as precision. Since you are not manufacturing these parts in a lab or in a workshop by your own hands, you will these devices or components and whatnot. So having these things being made using a machine with extreme precision would be very helpful towards manufacturing these products. Now, market trends and analysis. We've seen that the additive manufacturing space has gone up very high in recent years. As you can see here, 16% of the $80 trillion global economy is controlled by manufacturing. So additive manufacturing is aiming to seize this market and to push itself more into this space, into moving manufacturing into a more digitalized and digital space. To currently, the additive manufacturing for SLM machines method is valued at $2 billion, while polymer is $5 billion, which is a huge market right now, which the UAE is seeing to place itself into right now. You can see here the market size. The market size is expected to grow by 2025 to roughly $600 million US dollars. And we see the key trends in this, and pretty much the most important one, and the one that says 3D printing or additive technologies. FDM is the first thing that comes to mind. It's mostly used by consumers for rapid prototyping and your everyday printing of devices. So this has helped push additive manufacturing to the mainstream, even if it's for small scale applications. Binder jetting technologies also make up a huge percentage of the reason why additive manufacturing is much more popular nowadays, because this is what the architectural models are using for 3D printing and construction and 3D printing in more urban areas, as well as GE Additive. GE Additive is one of the largest manufacturing companies and well-known companies around right now. And they've opened micro factories in Abu Dhabi and Dubai, which has helped this country push forward into the additive space, as well as the top targets for the AM target industries are oil and gas, healthcare, automotive, aerospace, and construction. Now, 36% of 3D printing companies use SLM, mainly because the idea that it's growing at a very good fast rate. It's very reliable and has a multitude of benefits we stated before, such as brainstorming, prototyping, and precision. This number has been growing and will continue to grow in the coming years. Now, this leads us into our special talk with our guest speakers here today. We have with us Dr. Bashar Salman, Manoush Pillai, Mr. Asif Yusri, and Mr. Kira. If you can join us up on the stage right now. A round of applause. There's the mic right between you guys over there. So you guys can give a brief introduction to the audience over here and those watching virtually about who you guys are and what you do exactly. Starting with you, Mr. Manoush.
Hi, good afternoon, everyone. My name is Manoj. I've been in the factory manufacturing industry for around 7 years. Worked with multiple technologies. My specialization is in industrial AM in both metal and polymer. And I've been in UAE for around 2 years, close to 1.5 years now. And yeah, that's it as of now. Maybe we can know.
Hello everyone, thanks for joining us today. Pleasure to meet you all. So my name is Acer Yusri. I work as a solution consultant for additive manufacturing, and I have been in that field since more than 8 years in different parts in the region, Saudi Arabia, Egypt, here in UAE. Currently, I'm working in Falcon Technologies as a business development manager, where we focus more on contract manufacturing and how to support companies for digitalization. Falcon is a governmental company owned by the government of Iraq under the ITO. And we are more focusing on the industrial level, that how to digitalize these companies, how to make digital warehouses and these kind of solutions. Thank you. Assalamu alaikum everyone. Good afternoon. Thanks first for having this and for inviting me here to this group. My name is Bishar Khasawani from Khalifa University. Actually, my area is robotics. So how I'm involved with that basically, I'm building robots for structural building of modular building and things like so, cable-driven robots. And we are working also on developing a cement mixture that would suit such a technology. Also, I'm a founder actually of a new company, Dixa Robotics, developing robots for building management, trying glass building or cement building in order to clean or paint. So that's a brief introduction.
Hello everybody, my name is P. Mohammed Akram, and I'm the founder and CEO of Pro21 3D Printing LLC. 3D printing is my life. I started it back in 2012. As the first person to do it in my home country, Pakistan. Since then, I have been to United States, Germany, Turkey, Spain, Pakistan, then Dubai now. So Dubai is the place, UAE is the place where I'm gonna live forever, maybe. And keep growing my company and have a 3D printing hub of the world as the headquarters in UAE. Thank you.
Thank you guys, it was very interesting. To start off with our first question, this aligns more to everyone here pretty much. It's that a couple of years back, 3D printing was more of a novelty, more of a buzzword. You know, all these articles on the news, they would say this has been done in 3D printing, a lot of them would just be overblown and overhyped. And it wouldn't be possible to really create these things if they've been advertised. So it kind of created this stigma that 3D printing isn't there yet. But I know a lot has changed since then. And you can explain to everyone here what has really changed since then. Why is it right now, at the current time, a good place to be able to push 3D printing into more manufacturing?
Yeah, as you rightly said, there was a hype around 2012. 3D printing, that is a push button technology. In fact, when I was shifting my career from G Power to Wipro, I also had the same kind of thing. But then we hit a realization that there are some capabilities of the machine and some capabilities of the process, and the true success lies in how you match the product with the capabilities of the machine. So still that hype is there. Now if you see, there's a lot of acquisitions and there are a lot of money getting pumped into 3D business as such. I mean, you see, last year around 8 billion worth of investments are happening in 3D. So what has changed from 2012 to 2022 in 10 years? The capabilities of machines have really increased. Automation with respect to reduction in the amount of post-processing that we need to do in a part has decreased drastically. Automation in post-processing has increased. So we kind of understand now what the machine is capable and what kind of processes and what kind of parts can be built using this machine. For example, if you see GE has shipped around 300,000 nozzles of GE-NX fuel nozzles last year. GE-NX engine, they have combined 200 parts and reduced the number of parts required or in the assembly process required for that. So slowly, we are getting there for sure. It doesn't mean that you can manufacture anything in additive. I know he will definitely add to it his challenges in post-processing and how he approaches the customer's requirement and customer stories.
You're right as well, Mr. Moon. I think the idea that we become more educated on additive manufacturing. A long time ago, 10 years ago, people didn't really understand this technology. They were just like you said, push a button and something will come out. As you all know, that isn't the case really. So I think it's more that we're now educated and we're beginning to understand the capabilities of this technology.
Yeah, if I may add something here. So it's a common, I would say, I would use the word misunderstanding in the 3D printing whole world. Like when you see on the internet, if you write down 3D printing, you'll see crazy stuff. Like you just see 3D printing levers, you'll see 3D printing human hearts. I mean, we're gonna get there somehow in the future, but not soon. It has plenty of challenges when you look at the 3D printing as a real-time end product application. But you know, just like every other technology, there's like it needs space, it needs time to mature itself. Back in 2012, I mean, a 3D printer was produced out of a 3D printer. There was a whole rep community. So you used to just 3D print 3D printer parts, and you make more 3D printers. What I'm trying to say is like the technology has to evolve much higher, and it's not push button, not at all, even now. So you need to do a lot of design work, you need to do a lot of post-processing work, and 3D printing is just a step in the whole manufacturing process. But people just think like, I'm gonna 3D print suits, I'm gonna 3D print clothes, I'm gonna 3D print, water bottles. I mean, this water bottle that you have in front of you it's not made to be 3D printed, it's made to be injection molded. It's a complete different area, and we're trying to compete with the traditional methods, traditional technology, which shouldn't be there, I suppose. 3D printing has its own purpose and use where it should be used.
Yeah, I'd like to add to that actually. We should view it as a complementary to the traditional manufacturing rather than a replacement or a competitor with that. But also, I mean, we'd like to see, I mean, right now there is a proliferation of 3D printing in schools to educate our kids, which is very good. But to see it physically in the manufacturing field, we'd like to see more recent technology being developed here, more R&D within companies to be able to utilize the technology to its utmost potential. To use it as spare parts also has its own challenges from media point of view. So even existing companies cannot freely use the 3D technology as they wish. They have to consult with the providers of the different components. So it has certain limitations there at this point. But again, back to the point that we have to use it as a technology, we have to develop our own R&D in-house to integrate each other.
So I'd like to add also something that happened to me when I started in Egypt. It was the first 3D printing company there. When we were promoting 3D printing service in the market, people were asking like, are you gonna print it on 2D or 4D or 5D paper? Like, what's gonna be printed there? So they didn't understand what is 3D printing. Although that 3D printing has appeared for the first time, let's say 1987. Where the first SLA printer appeared in the market. So, and then 3D Systems by 1990 has created the first 3D printer. So after 30 years, let's say by 2010, we started 3D printing here in the Middle East. So after 30 years, we realized that 3D printing is there. And then after 3 or 4 years, we realized that there is a very high demand on 3D printing. And this is also because of competence between markets like manufacturers. They are competing on how to make it easy, how to make it reliable, how to afford so many materials. So all these steps that came up to here that make it more affordable now. Desktop 3D printers everywhere. In the future, you'll find it next to the microwave, for example. You're printing something that uses microwave. So I can see that it's because of competence between the companies and difference in material that has made up that change for our future.
So it's clear that a lot needs to be done to further advance, the additive technology. So my next question is actually directed to Dr. Bashar. I wanted to ask, in terms of the technology, like, is it AI, is it robotics? What are the kind of developments that will push this technology further?
Actually, it has multi-facets to develop technology to the next level. One is related to materials, one is related to design, to optimizing topologies, geometry. One related to artificial intelligence, to basically be able to optimize again based on the application, based on the load, how will be the distribution of materials or different porosities. So, I mean, all will be kind of intertwined in order to develop the next application, the next basically wow effect on 3D printing.
as well. If,
Anyone here has any suggestions they want to add on and what this technology really needs to push it to the mainstream, so to speak?
I would like to say materials. So, the major challenge in 3D printing, like, any of the technology chair, it has to have a stability and a seat to sit. What are you going to do next to it? So, similarly, 3D printing is an additive layering process. So if you call, again, I see it as more of a process of manufacturing the whole 3D printing. I don't know why we use the word 3D printing industry. There's no industry of 3D printing. There's the industry of 3D printers, by the way. So the 3D printing, the word, it's a process of manufacturing. That's it. And the real word what you use is additive manufacturing, not even 3D printing, like the gentleman said. So additive process, it's there. You can fasten it up, okay? You're increasing the speed, and nowadays things are coming up. But then fasting of this, like making it faster, is dependent on the materials most of the time. The process has to improve, but then additive cannot compete with like traditional methods. They start from a block of material. So cutting down is faster, or injecting is faster than producing layer by layer itself, So the most important challenge there I see is material. So, polymers are coming out that are stronger than metals these days. That is exactly where the 3D printing is going to grow and become more better for the particular purpose of what it is for.
Resilient material, of course, literally is a game player here. Also, from my opinion, it's the years of use. The years of use means that you have an FDM machine, you can use it at home, that's perfect. I'll give you, let's say, SLM machine, can you use it? No way, you need like 4 or 5 people to use the machine. I'll give you a holder machine, can you use it? No, it's so hard, it needs like certain facility conditions for all these kind of things. So I think once it becomes more easy to use, like softwares, what companies are doing on softwares, they are making it easy for people to use it, more affordable. That's like how it can change the game, or how it can attract more people to use 3D printer, especially in the industrial field. I don't need to hire like 6 people or 7 people to run the machines. If it's easy to use, someone can do the job.
Totally agree. Ease of use is something which is a differentiator for a machine, but with practice and skilled people, that will become easier. I mean, if you see any machine, if you give a mobile phone to a 5-year-old kid, he will use it better than a 40-year-old kid like me. So ease of use will come definitely. But the second point is cost of machines. If you ask me what is the real barrier that some industrialization of 3D printing has to cross is, one is cost of machine, then talent in 3D printing, and then design for additive manufacturing. So these are the 3 things which I feel that if these 3 are overcome, then we are almost there. Obviously, 3D printing earlier, people look at it just as it should be looked at a part of the process. As Piyush told, right now, in my experience in metal 3D printing, the actual printing takes only 30% of the total time of the part. So 30% is designed before, and around 60 to 70% is post processing. I'm sure that in polymer printing right now, the way the finish of a part is required here, you need to spend around 50% of the time after it has come out of the machine. So these are the things which are, I think, if it improves, like for automatic post processing, avoiding build failures. These are the things which should enable or make us reach that level of industrialization.
Also, I'd like to add to that, cost of the material, raw material for metal printing, for example, it's probably very high at this point. So unless and until that goes down, it will become a very niche market only. But if that goes down, then probably you can use it, or you see it in multiple industries and multiple applications. Also, the issue of certification and verification of these parts as they qualified, you should really qualify the machine. These things are very important for critical application and critical parts.
Certification is one of the most important things, especially in aerospace. I have seen one part which I was part of a project earlier. it took us 2 years to reach that level of certification that is required, and that is not a mission critical part in aerospace. So it's that they had an investment for certification. Normal companies cannot afford that.
To add on to that, there's also the next question coming up is very, very interesting one because I also have my own opinions on it. But it's the buzzwords that are being thrown around in which additive manufacturing is best suited for which industry, whether it's aerospace, whether it's oil and gas, whether it's healthcare. What industry do you guys think additive manufacturing is best suited for and which you can excel at?
I don't know if it's a tricky question because again, it's process that the manufacturing process that produce part for any application, any field. So I mean maybe whenever basically the cost is quite high, then you need justification. Then stiffness to weight ratio becomes an issue, then I can justify paying premium for producing parts for the aerospace or for the medical. But basically hopefully with time it will become more democratic type of situation where any application will be suitable for any industry.
I would like to say, I always say this to everybody who asks me regarding the industry and 3D printing, or they ask me, Arkham, what industry do you focus on? So I would say like this, that it's not about the ride, it's about the rider. You know what I mean? Like Vin Diesel said this in one of the Fast and Furious movies, by the way. So it's about the ride, like you have a car, you want to like drop a person to somewhere, or you want to just like, make it as a chauffeur, you want to make it as a taxi, you want to, what use technology is there for the capability. But then what you want to make use out of it depends upon you. Just like Product 21, we don't target any industry. We are a manufacturing service bureau. So sometimes a mother calls me, my daughter's Barbie doll arm is broken, can you fix it? And sometimes Edge Group comes up to us and asks, can you do the missile coverage? So it's about your manufacturing bureau, like 3D printing service is 3D printing is out there to produce things out of plastics or metals. Then it depends what you can produce out of it. When you question what best suits, I would say, since it's customized manufacturing, so there's no mold, you can have each and every item separate. I would say medical industry has taken the most benefit out of it, because while we sit there, not any single arm or limb will be similar. And that's where in one build of 3D printer, you can have 4 different designs and have the same manufacturing costs as per unit. So medical industry, aerospace industry, that customized bespoke for particular applications, that's where the bullseye is.
Actually, 3D printing appears to be a very game player in different fields. So we cannot specify like certain field and the other that okay changes the game here or this is the best use. But what we can do is more into categorizing the applications. Which applications are most used by 3D printing? Is it prototypes? Is it digital fixtures, molds, or is it end use parts? So these are the main 3 categorization for 3D printing, and I have seen that 45% of 3D printing are using it into prototypes, which is the main player for the applications, while only 1% is using for end use parts. You know how much, let's say, there is 32 billions dollars are spent on traditional manufacturing, while only 1% is using 3D printing for these end use parts. So why don't we save the cost for end use parts? Why we don't do something for end use parts? Why are we only focusing on prototypes? So here it's more affected by application and not certain industry, because I have seen so many industries are using 3D printers, so many are satisfied, they are using daily use, so that's all.
If you ask me this question, I would say I would split it into one is what we see globally and what we see in or in this region. Yeah. So in this region, we see a lot of use cases which people are not seeing in other regions. Like model making, one of the best industries industries in this region, so 3D printing is serving that. Can the same happen elsewhere? No. And there are certain entry barriers for 3D printing. So that has to be crossed. For example, if you see a metal 3D printing, there is a cost associated with the machine, the process, the people, the talent required for that. So you need a minimum cost for the part, the cost viability. Actually, that is what drives the industry. And what in globally I've seen medical industry, as Peter said, because customization is key, and that's one of the places where a lot of 3D printing applications are come up. Aerospace industry, the second one, because the parts are costly and you can afford to print in a costlier machine. So it need not apply to UAE as a 3D printing market. So my opinion, aerospace and medical is where the application will be more because of the entry barrier which supports, or the cost which supports the entry barrier to the industry.
So it's clear from this discussion that cost plays a big role in kind of limiting the ease at which additive is used. So in your opinions or your experiences, what do you think the future holds in terms of cost?
Okay, so as a cost, yes, I mean, I see costs coming down every day. There's many reasons behind it. The first is a lot of competition coming up. I mean, I'm going to speak on behalf of 3D printing service bureau kind of scenario. So when you say cost, I mean, cost is reducing because patents are going up in 3D printing itself. Cost is reducing because materials are getting cheaper. Chinese got hands on it. There's so many machines, so many printers. So, I mean, I don't know a single Chinese company who was producing 3D printer back in 2012. Now, the printers that are like $4 million in the United States are for like a fraction of the cost in China. I just recently procured 2 SLA industrial printers from China, and it's amazing. So what I'm trying to say, since as soon as the demand will grow, the cost is going to come down. It's going to settle, right? You know, when we started like in the beginning, 3D printing was for premium people. Now you have it in your homes. So the cost of material is coming down, cost of machine is coming down, and then the free information is online available. Coursera has so many 3D printing courses that you cannot imagine. Like you can have free trial and understand 3D printing the whole process in a day or two. So cost is depending on the whole demand. So demand is increasing. More 3D printing companies are coming up. Manoj, I think more than 20 companies now in the region. So that's all competition and everything going on.
Yeah, totally agree on the cost part. Machine costs in the future will come down. Material costs will definitely come down, and then our principles definitely are influencing the cost of the machines and the parts it has created. If you ask whether cost is a deterrent, yeah, cost is a deterrent, but I've always seen if you are able to deliver value to the customer, definitely cost becomes a secondary question. For example, we have customers who are ready to pay premium just to get the parts printed on time because they have their end customers waiting on their commitment of delivering a component, and this might be a component which is 100 dirhams, but they are ready to pay 150, 200 dirhams for getting the part on time. So it always depends on situation and what is the value that we are delivering for the cost that we are giving to the customer. So if a power plant is going to shut down for the want of a part of 1,000 dirhams, they will not hesitate to procure it for 2,000 dirhams. So, yeah, so it's a cost versus value delivery that we need to identify. Definitely cost is the thing, but always cost versus value is what we should always look at.
I think the cost going down will help a lot, but again, we have to bear in mind that this will not compete with traditional manufacturing. It should complement it. I mean, I can use it for the tooling instead of paying $100,000 for changing the mold. I can change certain inserts inside it and produce a bottle with different design every week. So to increase the competitiveness of the manufacturer locally, but without replacing whatever they have right now, complementing their game. Actually, I see it by more into not the cost. So I don't see the cost of 3D printing is high because whatever we can do by traditional manufacturing, don't do it by 3D printing. It doesn't make any sense. Why are you comparing traditional to 3D printing?
So, for example, someone is asking to manufacture for him a device kitting. Ask him if he went to traditional manufacturing, how much he will pay for one piece, and how much he will charge for 3D printing. You will find you way cheaper than what you will do with traditional manufacturing. And that's why the cost of 3D printing compared to the value that you're giving is completely down. It's not high as people. So it's from the perspective of the customer himself. It's more understanding that the value that is given can cover the cost that is being, which is completely low.
Okay, thank you. The cost of material, you are talking about for titanium, for example, maybe a couple of thousand dirhams. Compared if you buy it as a bare material, it's fraction of that. So there's always a cost fraction, but again, yeah, as you said, the value has to be basically conveyed to the customer.
From manufacturer point of view, of course, the costs are high, but in the end, he will close if he's not covering his costs. And at the same time, from customer's point of view, or from customer perspective, I can see that he's not paying that much. He still needs to pay more to get more like affordable solution. Because what we are offering in the market, like unique solution, you're giving someone something that cannot be done. That's where 3D printing comes. You cannot manufacture it traditionally.
Especially if you're talking about, for example, very specialized niche heat exchangers for aerospace, for example, application or things of that sort. So we have internal cavities that no way you can produce it with any other manufacturing process. So if you have the user or the client really understanding the value and is aiming for optimization, then yes, you will find his aim and his.
Thanks for these answers. Our final question for this event is about the Internet of Things when it comes to additive manufacturing. So right now you see more and more of these 3D companies provide services called the on-demand printing, where you need to have any of your physical items stored in a warehouse. They're all stored on the cloud. So they would take STLs or scans or designs of your pieces and then just save them on the cloud, and then they can be printed whenever, wherever, on demand. How feasible is this as a method of to push this technology forward? And what do you guys think about this kind of technology right now, where everything is stored digitally instead of physically?
Quickly, I think the biggest profit margin manufacturer of the equipment, capital equipment, it is through the spare parts. So it's very difficult for them to give up the STL files or the design files for the customer to utilize as he or her wishes. So it means basically complete kind of paradigm shift in the way they conduct business. Probably they'll be charging for these files, of course, but that will, if that happens, and basically you get buy-in from these suppliers, then it will usually change the basically supply chain and the storage cost, etc. So it will change the cost structure for both the user and the supplier.
Actually, I'm gonna talk quickly about two main things, which is first thing digitalization, and the second is on-demand services. So in-demand is what we are doing in the industrial field, that you have certain spare parts, then we replace these spare parts with digital files, then he just can print from his facility, pressing a button, then collect it next day or whatever the technology, then he can collect it. And this is more digital warehouses is focusing on the industrial field. What we will see in the future is digitalization. Digitalization means that you will be sitting with your phone, opening your phone, then logging in, let's say, Apple Store. Then, okay, I want sunglasses, but I want these sunglasses customized with certain things. So you can customize it on your phone, then print it using the 3D printing service bureau or contract manufacturing company, or you want a customized, let's say, insole for your phone. So you will open another software and download it. Just one click, then you can collect it. It's like Amazon. He says to you 1 to 3 days for shipping. So it will be the same for 3D printing for customized solution, which is one is focusing on the consumer and the other is focusing on the digital warehouse is focusing on the industrial field.
So what I understood from the question, so you're asking for the supply chain and how companies are storing their parts digitally on cloud rather than, keeping them in the warehouse, am I right? Okay, so this is one of the most highest benefits of 3D printing is that you don't have to have warehouse costing. So imagine warehouse costing for Amazon. Imagine warehouse costing of a Dubai Metro. I'll explain something. So Dubai Metro, for example, if it's a functional metro where so many people are traveling every day and working and living and everything, tourism. If a small part of the whole Dubai Metro, one of the cabins of one small part, cabins, I'm not sure, but you know what I mean, like one of the small parts, if it is broken or lost, so that means that they have to keep a part of the entire, I don't know, a million pieces to have it once in the warehouse, they have to stock. Imagine you have a 3D digital file of the whole background. And whenever something is broken, you just produce on demand. So, I don't know any of that. On the contrary, on traditional methods, you would have to have molds of all of those items. And then you'll not run the mold for one piece. You know what I mean? So, yeah, this is one of the most areas of 3D print areas of this whole process where 3D printing is very beneficial. We did a job for DHL. So they have these rollers that guide the packages on the rail. And we have now like a digital file of the roller, and whenever around the world something is going to be broken, they can use it. So this is just one step from DHL to try to digitize themselves and then reduce the warehouse costing. It's not on a scale, but it's possible. And that's one of the, I would say, that's one of the things that is most exciting. Tomorrow you're gonna go Mars. You're not gonna bring factories from here to take there, So you're gonna have 3D printer there and have digital files or whatever you need here. This is where the whole 3D printing thing started from NASA. They needed, it's a story, but I'm not sure it's true, but it just makes sense. So there was an astronaut on NASA losing a wrench. Have you heard that story? And they said we need a rapid prototyping technology. And that's how the whole concept of 3D printing just wanted to, buckle up. So it's just that on a remote area, you need something. By the way, United States Army uses it. So when they go for any war scenario, so they go to a remote location, they have the printers where they can print the items that they're not available with. So it's quite very exciting when you think about it.
So I'll become the devil's advocate here. Yeah, so working with industries in the past, what I've seen is they have two kinds of spare parts. One is the very critical ones, which they can't afford not to have stock of because their operations will be critical for that. And then there are items which, even if there is a long lead time or even if it's not there, they can afford to run without that. So typically industries when they run the critical spare parts, they will ensure that it is there, it is available, it is running. But can they 3D print it? Yes, obviously they can, but the OEM will not give them the control. They'll say, if something breaks in the part, while it is running, it is not our responsibility. So nobody in the procurement or the supply or in the factory who is running it will not touch that part. So that's a big gap over there. How to address this gap? As Sir was rightly pointing out, certification, reliability, increase of this technology, then advancement and cost of how to reduce the cost of this part. All these things will have a play. And right now, this is the right start we are doing. First of all, OEMs will not give the 3D CAD model. So how to get the 3D CAD model? Because 3D CAD model is the first step in having a 3D printed part. There are companies or there are enough know-how in the market to re-engineer and reverse engineer this part. But do they have the capability to test this part? A turbine blade, if it breaks during its top speed of spinning, it will break the wall and break the wall of the other building also. So nobody will touch that. those know-hows have to increase, and OEMs have to release their, it will happen. It's just a matter of time. People understand the technology, people have their faith in the technology, and the technology itself matures to that level where we can produce the parts without defects, with the correct proving of the technology and proving of the part. So we will definitely reach there, but it will take some time according to me, with respect to certification and with respect to the cost and other implications with the operations of the parts. So definitely digital inventory is a starting point, and 3D printing obviously will take us to the next level.
Yeah. Also, some of the parts could be copyrighted, so there could be some legal issues that one has to be aware of, and shouldn't influence on that for bigger companies especially. Plus, basically, warranty issue. And probably if you put any foreign part in a machine, you lose the warranty. So these are issues that probably no company will conduct unless you have basically some agreement early on to tackle the issue. Also, I mean, maybe you mentioned the IoT. The ease of printing maybe will enable implanting sensors in the different parts, and will become easier to monitor every small part that you have in a machine because of basically the ease of implantation.
So we come to the consensus that throughout every new piece of technology, no matter how wonderful or how much it can change things, there's always these set of challenges that we might face and we have to overcome. Whether it is a copyright infringement of printing the pieces, whether it's cost, whether it's legislation, whether it's a lot of things. But the idea is that this technology, you guys can see that it can overcome these obstacles and become the future of manufacturing. So thank you guys for this talk. It was wonderful having you here. For the last part of this panel, we're going to be taking questions. We're opening the floor for anyone in the audience. So we'll pass around some microphones to anyone who'd like to ask any questions.
Yeah, hello everyone. I'm Mustafa from American University of Sharjah. So basically, my question is like right now, which I'm seeing around is like polymeric 3D printing is pretty much mature enough. Like it's kind of thing like which is easy to manufacture, and the parts properties are even like way better. So, but when we discuss about the metallic 3D printing, so it seems like there is like we're targeting some not very critical parts. We're just targeting usual parts just for prototyping purposes, just to see how it looks and these kind of things. But when we're discussing about the critical parts, so I can't understand where our industry is standing right now at the moment, like to what extent we can develop those parts. Just like developing something out of aluminum, like a simpler one, is kind of easy thing. But when you talk about a high-end alloy systems, like especially for aerospace applications, if you talk about an aerospace grade aluminum series, so it's way critical to develop that using 3D printing technique. And yeah, if somebody does, it should have like not 100%, it should have better properties than that. So I think like I need an answer from you guys, like where we are standing at the moment and what would be the step forward in this scenario.
I think already it's being used in critical applications, fuel injectors, for some years now. And I think there is no limit on which material you can use for which application, especially in the aerospace and for critical applications. The issue of certification and basically qualification of the process to ensure that yes, the part that you're getting will go on the plane on critical parts or not. So I don't think there is an issue.
If you question, like, just a general question, you said, where do we stand? And as per requirement of end use application, what are we exactly capable of? Is that a question?
Yeah.
Okay. So you can actually build a plane in terms of the city. That's the capability right there. Do you know that there was a whole boat that was 3D printed? So capability is there. Feasibility, not sure yet. Would you bring that boat to a scale where everybody else can make and use, or a company can produce a 3D printed boats where you can, sail? So feasibility is a question, like one of the part of feasibility certifications. Will the UAE government allow the 3D printed car goes on the road on RTA? The way police, I was doing a project with them. So exterior parts are not yet allowed. You can do the interiors. We've done the dashboard of the Dubai Police, for example, right? We've done so much sophisticated drones and a lot of things, guns, that the plastic part of the guns, I mean, you know what I mean? But would it be allowed to do? Because it's not yet proven that it's gonna work and it's gonna be safe. You know what I'm saying?
Yes.
So flying cars are not a future. Jetson is gonna be very soon. You know what I mean? You know Jetson, by the way, like it's a cartoon. So they're there, but they're not yet ready to go in the market. So capability is there. And plastics, I mean, again, the plastics, the plastic that peak, for example, it can compete metals, It can be used in aerospace. It's already used in aerospace. The SpaceX used metal 3D printing in one of the parts of the rocket. So it's used, but then it's not cost effective yet. It's going to be, but it's not there yet. So it's not that. Capability is high. They already transplanted a 3D printed liver, 3D printed skin, 3D printed air, literally. So these are there out there, but it's just not ready yet to be in the market. So the certifications and all those parts.
So can we say that like in terms of properties, we haven't achieved those superior properties which these traditional method like traditionally casted metals can put in. So for the certification perspective, like that's why we are not getting the certifications or what's the
certification has to follow a process. It's not necessarily that we haven't achieved the property. By the way, there's an information that we have here, and you have it on Google, and then there's information that exists. For example, it's a United States is able to have transparency, like what do you call it? That they can disappear. Do you know this?
it's kind of a double image technology.
Camouflaging at a level that you can see through a person. But then capability is there, right? But then will those rays be beneficial for a person that is using? Why don't we have wireless charging? This is an iPhone. You think iPhone doesn't have the technology to wireless charge this phone? I have made a circuit, you can check it on Google on the YouTube. I have produced electricity, not electricity, but I've made LED to lit through the micro from the radiations of a phone. You know what I mean? From the radio waves. You can produce electricity out of it. Why don't they do it there? We're not sure yet. If I put it beside, do you remember in the early times they used to say, don't charge your phone and use the phone, it's gonna bust. That was Hawks, by the way, right? But so we don't know the consequences of these things. So if I can do body kits of cars, we do it, we've done it. But they use over 3D printed body kits, then going to fiberglassing mode. Because the heating temperatures of the body is crazy. 3D printing, like Mohammed would understand that. 60 degrees is the temperature sometimes in summer, and PLA melts. The 3D printing plastic melts. So there are a lot of these kind of questions. Capability is there's some information that these few companies know here, and there's information that out there that's like under R&D at the moment. They're far ahead of us. So capabilities are there for sure. But then feasibility.
There, Mr. Ganesh.
That's another.
Okay, sir. Polymer, as you said, yes, it's a very mature technology. You can make almost any part in polymer. Only limitation will be size of the machine and the cost of the part.
Right.
But when it comes to metal, there is one key thing which will limit you. One is support structures, which is like a necessary. You need to have it because you need for building the part, and you don't want it because it's a waste of material, it is a waste of time, energy, etc. So if you ask for what is the capability in metal 3D printing, we can print super alloys, zinc oxide, 18625, titanium 3D printing, there are two, three things which we need to take care. One is the porosity of the part. In polymer, it doesn't matter. You know, you can just coat it or something and then it will work fine. But when it comes to the actual functional metal 3D printed parts, what happens is if you have porosity, it will fail in operations. So you need to ensure that the part is at least what 3D printing company is paying is 99.9% part we can produce in metal 3D printing. It is true. EOS claims it. Yeah. You know, Farsoon Technologies claims it. But where is the porosity? Is it aligned? That 1.01 porosity, we don't know where it is. Is it aligned porosity? It will initiate a crack. Only thorough testing and thorough analysis can do. There are technologies, and each day we are improving. Inside monitoring for the parts which is happening there, we can find out where the porosity is, not by testing, but by non-destructive testing methods. CPC casting has been in practice for not centuries, since the time we know casting is there. All other metal cutting practices, it has been there for 200 years. So we know where, which part, how it will fail, because we have seen so many failures and committees have been formed by ASTM to analyze the failure and find out where the typical failure will happen. But AM as a technology, it has been around 20, 30 years. Metal 3D printing maybe around 20 years in actual practice. So it will take time to understand the failure behaviors. It will take time to understand what are the things we should take care so that this failure will not happen in the future. ASTM Committee 14 is working on that. There are many parts which are being certified by aerospace companies and FAA, the Federal Aviation Association, and ESA for use in aerospace applications. So we are reaching there, capabilities are there. The question is, should we do it? Yeah. It is, there are multiple factors affecting that. Price, maybe something, it may be design not suitable, but capabilities are there.
For a single part, no doubt that the specification and the properties will meet the requirement. The issue is that the process is very sensitive to the material properties, the raw materials that you are using, the running conditions of the machine, the speed, the laser power, any fluctuation will impact the mechanical properties of the final part. So the qualification is not only the raw material of the machine itself. So either you do 100% inspection of every part at the microstructure level, or basically somehow certification will evolve to be able to certify a particular machine that has to stay within certain tolerance of running conditions. Okay, that's basically the way that people are viewing the 3D printing and certification.
Thank you so much, guys. It's like a very clear discussion. So yeah, thank you so much.
Especially, I have actually two questions. One is like I have seen 3D printers working for polymers in Pakistan, and it is like we melt the polymer and then we print it out. But for metals, is it the same thing, or if we are using powders and then we are trying to do something, then how we compare it to the powder metal and the so then after this I will ask you.
Sure. Right. Okay, so your question is that just like in plastics and 3D printing, you melt the plastic and then you print the material, right? So your question is, in the metals, is the same process or not? Is that good?
Yeah.
Okay, so honestly, it's 3D printing is just changing the state of matter, the three states of matter, right? So in thermoplastic, it's a solid, makes it liquid, then solid. Thermoplastic, it's just a string format. I mean, it's a shape of the plastic, but the matter is solid. So you heat it, you melt it a little bit, and then you fan it and cool it down and make it back again, right? In metals, there's a company Desktop Metal, right? So Desktop Metal has this, again, the material is like melted and then poured, and it's like then, you know, the item is in the green state. And after that, they go to furnace and heat it further, and it goes to the final stage. Similarly, powders, it's always metal will be melting. Otherwise, there's a binder, but in the final place, it will be heat involved. So it's just because it's metal, you want to create it out of, but it has to, produce in a shape. You want to shape a metal, you have to melt it. So even if you don't do 3D printing, to produce something of metal, you have to, cast it. Or you have to subtract it. If you have to cast it in an organic shape, you have to do that process. Am I right, Manoj?
Actually, there is a selective laser sintering in which you are not reaching the melting point, so you are sintering or fusing metal powders particles together. SLM, selective laser melting, you are reaching the melting point and basically bonding the particles together. So you have both basically particles.
If I may add one more thing, this is the latest addition to additive manufacturing process. It is called cold spray additive manufacturing. In that you don't have any heat interaction. It is just the kinetic velocity of the part of the molecules which make them adhere to each other. It's a new one which is coming. Yes, a very high speed.
But then after the process, you have to again go to furnace.
No, it's not required.
So just like a metal powder.
Absolutely.
Wow.
But that is for, I guess, it's for coating purpose, or we are also using it as for additive?
It is now coming up as an additive manufacturing technology. There's a company called C3D in Australia. They're doing it. They have a machine for doing that.
And the other one is a general question, like we have seen an LED which has some metal wire and then there's plastic casing. So can you print something like that with two different materials in one go? Is it possible?
We will do it.
No, if you visit me someday, a Product 21 in Jebel Ali industrial area, I'll show you 4 materials at one time.
Oh, that's great. So I will
It's polymers. Sorry, again? Polymers. Even it's a process you can apply to everything. This company, Stratasys, they were here today, they met me today. They have a machine called J750. Just Google that thing. It can produce more than 6 to 7 materials in one go. Wow. And then some is transparent, some is rubber, and it's just like mind-boggling,
We have the connection to 50 and bond this material.
Hi, hello. We just talked about Jason the machine.
Yes.
For that, but we have never seen the machine in the region.
It's
I
not,
mean, like in terms of service application.
you're where are you from?
I'm from Technology.
No, I mean, what country are you from?
I'm from India.
In India, it's
Yeah.
there.
I'm interested that in this region, in the UAE,
It's there.
it's very definitely, but no people are providing services with
It's
Jason.
expensive.
Yes, that's what my
Feasibility.
Yeah, I mean, like, given the chances that you're making a couple of years for the rest, do you think it's worth buying a machine for
Inshallah, I'll buy next year.
Saving money.
So it's just expensive, my friend.
Yeah, it is definitely.
And that's why it's not available. Again, FDM, what you see, the technology that Mr. Manoj is dealing with, HP, that machine was a dream for me in 2012. It was like, oh, wow, this is like, a SpaceX rocket for us, you know what I mean? And we can go to Mars. But now it's like, we have it. It's available, it's affordable, you know what I mean?
Do you see people coming to you asking for multi-material products or multi-color products? Because I've been in this market for 3.5 years, but I have never seen anybody come to me saying that, maybe they have intention, but when we talk about the pricing, definitely they just get back to affecting. But it's not I'm not talking about the individual, but definitely it will be essential for the individual, but for the company. Okay.
I love your question. So he says that I'll just like elaborate the question because Karmik is right. So he's trying to say is like, do you have a person that comes up to you and say, I need multi-material? Is that a question? So trust me, when people come to us, they don't know what they want. Can you believe that?
He is kind of
Yeah, I mean, they come back to us and say, one day, my phone number is on the website, right? Because I enjoy it. So I got a call someday, said somebody saying, hello, can you do zebra crossing 3D printed? I'm like, I'm just like, zebra crossing 3D printed? No, we're not a printing company, sir. We're not graphics 3D printed. not graphics printing company, we're a 3D printing. They have 3D printing, 3D tech. I'm like, no, manufacturing, not printing, you know? And then people will come by and say, hello, I have a small IKEA lamp, it's broken, can you 3D print? I'm like, no, it's gonna cost you more than IKEA lamp. So people don't know what they want. Like, you know, they just come back to us with the problem. They're like, I got a call from one day, like, we have a Toyota Prado. Can you put a Tesla screen in there? And that's what they want. And then you work out and build the thing, visit it, scan it, get the scan out, then make a prototype. After prototype, you do a test fit out, get the approval, put the actual thing, and have the car run on the road.
So adding to this, Tesla will see you.
No. It's the Tesla screen is an example for them. Again, they don't know yet. So for them, it's just like a LCD, a big LCD in the Toyota Prado, you know? So it's like that.
So I have one more question on the same thing. Talking about different industries, whatever. But when we're talking about medical, when we think about strategy, medical, they have huge applications and everything. But again, do you think that we are not clearly, catching the medical applications here doing time or technology? Because currently what I'm seeing, we are doing the inputs, we are doing the apothetic for medical. But when it comes to pre-surgical thing, scientists have very good, technology where we can use it. But where is the market for this one? Basically, do you think the UAE market is really using that kind of technology in terms of medical?
Of course. I mean, I think the way
Because when there is no service provider, so how are they using the?
again, for service providing of JSON50 services, you can just buy it now while you're in UAE. There's an online e-storage of 3D printing like iMaterialize where you can go and just buy the items you require. You upload the file, you just mention what you require and deliver to your UAE.
Even to the doctor or the hospital, they are using.
Yeah, they're using it. They're ordering from India, they're ordering from many different places. So the particular JSON50 or any other technology is today's world is fingertips, literally. Just try Googling it, it will come up. Maybe a new one that I don't know. So it's like every day 3D printing is growing so fast. So it's out there, you just need to reach out.
I think for medical, now the industry is heading toward medical, especially if you see the first 3D printed prosthetics. That was years back. That was maybe 2004 or something. That was the first 3D printed prosthetics. So what we can see in the market that people are now going toward 3D printed, especially customized insoles. Instead of getting normal insoles, they are doing the 3D printed one. Also, it's the material that is SLS technology, which is provided by EOS, is FDA approved. Then HP also is providing food grade. So there is in the material itself, they are trying to bind it or make it more proper than with direct contact with the body, that it doesn't make iteration or it doesn't make like scratching or these kind of things. If you see old ways for hand casting, I see some hospitals here in UAE interested of hand casting. Why? Traditional ways is way cheaper, but it doesn't make sense. Like it wastes so much time for that. Maybe in the future when the cost of 3D printing goes little lower, there will be more demand on this medical solution. But if you compare for ankle foot orthotics, if you're doing it with carbon fibers, you will find the cost way higher. So you go with 3D printing. So it still depends on what technology are you doing. Traditionally, then you can compare with 3D printing. Okay, it makes sense here. It doesn't make sense here. So in the medical field, there is so many applications itself. Cranial health, there is so many applications that you can see which one is more effective. That's all.
Related to the different field, you have to get the insurance companies on board to be able to pay and cover the cost of these operations or these prosthetics. And back to your first question, having multiple materials. When it comes to leather, for example, we have at African University in our manufacturing center, we have a NEOS
metal filter that has 4 lasers with size filter. If you want to switch from one material to the next, it takes a couple of days. So switching from aluminum to tank, for example, it takes 2 days in order to avoid contamination. Spacesuit for the operator to ensure he's not inhaling the bad stuff, etc. So it's not easy. We are not there yet to have metal multi-material. But in polymers, yeah, the basically field is quite filled with examples of multi-material.
Alright, so any more questions? Well, I guess that's it for the Q&A section. I'd like to thank
our speakers here today, Mr. Manoj, Mr. Asad, Mr. Bashar, and Mr. Khair Akram for attending this event today. For the last part of the event, we are going to be giving a small tour of the additive facilities here for those who want to attend and view and see what's happening inside our facilities. Aside from that, we're concluding this event right now. Thank you very much.
Behind the screen. Oh, we look different. Behind the screen. How did you
How are you?
Glad to see you in person.
Yeah, same here. Good to see you. I would like to, actually, I'm in the middle of preparing a, what do you call it, a robotic arm.
Okay.
For
So the arm?
FDM
Yeah.
for now, I don't want to go into concrete or something, but FDM robotic arm is very interesting.
Okay.